Oh, okay, my friends. So hopefully you've opened up the spreadsheet now. Make sure if you have other spreadsheets open with them, close everything, including this one, and then reopen just this one. Anytime I give you a spreadsheet like this moving forward where you've got the iterative, it's called an iterative calculations. I'll explain that as we go. They goof up for some reason when you have more than one spreadsheet open. I don't know why. It's kind of like I don't know why that math error happens sometimes with the probabilities, but it does. So when you crack it open, you'll see 6 dice. I color coded them. I tried to use rainbow colors. I know there's 7 colors in the rainbow, but I treated indigo and violet both as purple. So this is going to look very, very similar to what we saw in the videos for today with 1 and 2 dice. Except I've left off a column I want you to code right now. But before you code anything, I just want you to re-randomize these dice a little bit. Right now, I've got 2 4s and 4 6s, which is actually a pretty cool result. I'm going to press my F9 button and get some new dice there. That's a couple 1s, some 5s, a 3 and a 6. That's some book-ended 6s, actually 3 6s, a 5 and 2 2s. You might also have to hold down another button with your F9 button. So try, if the F9 button isn't working by itself, try combining it with either the function button, the FN button, the control button, CTRL, or the, if you have an Apple, the command button. Hold those buttons down first, then press the F9, and sometimes that'll get you your re-randomizing. It really just depends on the computer you have. If you get stuck, like I said, just email me and we'll figure it out. Now, what are you looking at here? What are we looking at? Well, I wanted to kind of look at the claim that I mentioned in the video. That some students say, like, if you roll a die 6 times, then you'll get 1 each of the faces. Well, you can see right now in this particular example right here, that's not true because I see 2 4s, 2 2s, a 1, and a 5. Let's do it again. I see a 5, a 1, a 2, a 4, a 2, and a 4. So again, we're not getting unique faces on all these. And as a matter of fact, as I keep doing this, I haven't seen one yet. Now, actually, I just lied to you. I did see one. I just didn't see when it happened. And I can tell that because of this one that's right here. Now, just real quick, what's happening is we are currently in this column looking at how many distinct die faces we see. So right now, the 1 here implies that we see 3 distinct numbers over here. And here they are, 5, 3, and 6. There are multiples. That's why the number is less than 6 total, because you're seeing multiple dice showing the same thing. Let's re-randomize again. Now, once again, we are seeing 3 distinct numbers. I see 3 1s, 2 5s, and a 4. I'll do it again here. Now I see 4 distinct numbers. I see 2 5s, 2 3s, a 2, and a 4. Now, at some point, we did see 6 distinct numbers because you see this 1 right here? That's the cumulative. That's the cumulative count. So if I hold down the F9 button and let this thing keep on going, oh, 1 just happened again. Oh, 1 just happened again. But you can see how rarely it's happening compared to the other results. As a matter of fact, looking at just this data right here, it looks like most of the time we see 4 unique values. But let's create the probability column that we were talking about in the videos today. So I'm going to label it P of X, just like I did in the videos. I'm going to make it bold because I'm feeling saucy. Make the whole column bold, actually. And now, a probability, as we've discussed for a few weeks now, is just simply a event space divided by a sample space. So what I'm going to do is I'm going to go equals, and then I'm going to click on this cumulative right here. And then I'm going to hit divide by. I'm going to type the word sum, left parentheses, and then just click on column AB. This will add up all of the values in column AB, which is what we want because that's all the trials we've run. Now, that shouldn't be a surprise to anybody because we haven't seen one distinct face yet anyway. We haven't seen all of the dice show the same thing. I'm going to copy this formula down, and we got some percentages right now. And then what I'm going to do is I'm just going to hold down the F9 button and let this thing run. Now, if you run enough trials, you will eventually see that one distinct face option pop up. The downside is it takes on average about 8,000 trials for it to happen. I'm going to offer that as for something you to think about later in the homework. We actually do see quite a few instances of 6 distinct faces, and I'm sure we'll get more. But by and large, as you can see, that only happens about 2% of the time. And now we've got some stabilization. Those probabilities are starting to stabilize a little bit. We see that the 51%, roughly half the time, you see 4 distinct faces. That means you either get 3 of one number and then 3 singletons, or you get 2 each of 2 numbers and 2 singletons. Most of the time, you get between 3 and 5 distinct faces, but very rarely, very, very rarely do you actually get all 6 of the numbers on any given 6 rolls of the dice. I will let this puppy dog, I'll hold it down and let it run, and I'll speed up the process a little bit, and then I'll stop the video when we actually get the occurrence of that first one to show up. But otherwise, I think you've got everything you need to answer the next few questions on the homework, so go get them! There it was, about twice as late as it should have been. But it finally showed up. And by all means, you could very easily have turned this video off by now, but I'm just for grins going to let it go again until I get the next one. It makes me laugh so hard. I love randomness. I love randomness and I love probability. Let's take a look at how many trials we've seen. So we've seen, oh my God, just about 16,000. And like I mentioned before, it's going to take on average about 8,000 until you get all the dice to match. And literally what we just saw was that. It's just that the first one was really late and then the second one happens like that. And I cannot think of a better way to describe the flukes of randomness than that right there. I mean, the average of 8,000 trials per does not mean that it's going to happen on every 8,000. It means that on average, it's going to happen every 8,000. Anyway, I absolutely adore that. Okay, you've seen me goof around enough with this spreadsheet. Go do your homework.